Hey everyone, I want to make a video today on Triton. So Triton is both a compiler and a language that you can use for primarily for deep learning. But the main advantage that I wanted to kind of showcase here is just to give you sort of a fundamental basis of what is the advantage of Triton over, say, PyTorch. And the main advantage is that it gives you direct control over SRAM and HBM GPU memory, so you can use that to your advantage. I'll give you a quick overview of some GPU fundamentals, and then what I wanted to do is we'll basically go through writing softmax. So this is basically from the tutorial that's available, but hadn't seen any videos kind of walking through it, and hopefully I can add some additional insights to it. But basically we'll code softmax in PyTorch or eager PyTorch, and then we'll code the same thing in Triton and kind of do some comparisons between the two. So hopefully give you a feel and understanding for how to code in Triton. So let's get started on some GPU fundamentals. There we go. So this is just a generic GPU overview, and the images from NVIDIA. But specifically what you're looking at is kind of the internal components of a GPU. So these SM is streaming multiprocessor. And we've got, like, for example, on an A100, probably have 108, I believe, of these. So that's why I've got a whole number of these here. But the main difference here is we have this thing called L2. So this is your programmable cache. So each streaming multiprocessor has an L1 instruction cache, but what you can control and program is this L2 cache. And DRAM is basically the more global memory for the GPU. And when you say, for example, I have a GPU that has 40 gigs or 80 gigs in an A100, for example, what you're really referring to is this DRAM. And when you're coding in PyTorch, this is basically what's happening. All of your data structures and so forth are here. Obviously, they do things in the L2, but you, in terms of programming PyTorch, are basically programming in here. With Triton, you basically move into having much more finer grained control. So you're able to move things back and forth between the L2 cache or SRAM and the DRAM. And that's basically the primary, what I would consider like the fundamental speed advantage that you can leverage is if you have to do a series of operations, you can move things onto the L2 cache, have the streaming multiprocessors handle it, but do a whole series of operations and then move it back to DRAM. In eager mode PyTorch, it doesn't know necessarily what you're going to do for your next step. So it's going to issue an instruction, execute it, and bring it back. Issue another instruction, execute it, bring it back. And so this memory bandwidth right here is much smaller than the speed that's happening on the L2 cache. And so that's your primary differential in terms of leveraging things, is that you are able to, you can plan ahead, so to speak, for the things that that you want to do on the GPU. And as a result, you can bypass, or not bypass, but basically be smarter about moving things to L2 cache, doing a series of operations, and then bringing it back. And so that's your primary speed advantage, and the reason that when you code in Triton, you have finer grained control and hopefully get some performance improvements as a result of that. So let's jump over to do some coding. I want to do PyTorch eager softmax first, and then we'll go the same thing. This is just a forward pass in Triton.